All right, just a quick follow-up to some normal distribution rules here. So I've got an example where I'm looking at a truck that's got a carton of eggs, each weigh an average of 2 pounds, and I have a standard deviation of 0.1 pounds. A histogram of these weights looks very much like the normal distribution. So here's the normal distribution curve, and what you're going to do is you're going to take that information and you'll label it to below that normal distribution. So in this case, it has an average of 2.0, which is why right in this center here, I put that average at 2.0. Then it has a standard deviation of 0.1. So every time I moved one standard deviation to the right, I went up by 0.1. Every time I moved one standard deviation to the left, I went down by 0.1. So I just added those in there. And then the question is, what percent of the cartons weigh less than 2.1 pounds? If you remember, this 50, or the average, the mean right here is at the 50th percentile. And so if I'm wanting to look at less than 2.1 pounds, that means I'm wanting to look at this much right here and this much right here. Okay, so we know that this right here is 50%, and we know that this right here, from here to here, is 68, and this would be half of that. So this would be half of 68, which we know is 34. And when I put that 50 and the 34% together, then that gives me 84%. Okay, and the next one, same problem here, labeled the same way. What percent of the cartons weigh less than 1.8 pounds? So, again, I know that from here to here, from the mean to the edge, is always the 50th percentile. So there's 50% there. And then the 1.8, if you measure everything from the center, it kind of becomes easy. The 1.8 is this much right there. Okay, so it goes to that second line. So it's half of 95. And half of 95 is 47.5 right there. Okay, now to answer the question though, the question is what percent of cartons weigh less than 1.8 pounds? So that much is this right here. That's the piece in question. So in this case, it will be 50% minus 47.5%, which of course gives you 2.5%. And the last one, what percent of the cartons weigh more than 1.9? Okay, again, if I'm measuring from the center line right here, I know that this is 50%. And more than 1.9 would be, what if I need to get to the 1.9 more than that would be this, I need to add this chunk to it right there. And of course we know that that's half of 68, so this is 34%. And 34 plus 50 again makes 84%. All right, then this next problem is one that tricks people all the time. What is the mean and the standard deviation for this normal distribution? So you need to figure out, first of all, what the mean is. And the mean in this case will be halfway between 15 and 75. So if you add 15 and 75, you get 90, and half of that is 45. Okay, so the mean is 45, and I've labeled some points right there. Many, many, many people tell me that the standard deviation is 30. Okay, I'm going to just write this down first. Mean is 45, standard deviation. Lots of people want to tell me 30 because they go 45 to 75 is 30. So the standard deviation must be 30. But remember how normal distribution curves go. You need to fit 3 standard deviations to the right of each curve. Okay? So this much right here is what 1 standard deviation is. I need to fit 3 of them until I get to that far edge of the curve. So from 45 to 75, that's 30, but that 30 is 3 standard deviations, not 1 standard deviation. So if I split that 30 in 3 parts, each one of them is 10, which makes this jump right here, which is 1 standard deviation. That's how much 1 standard deviation is. That standard deviation is 10. Okay?